Today on the bench we've got an RSC Diatonic or A2 A11 valve amplifier. It's basically a Mullard 510. So we've got an ECC 83 input sort of tone control, ECC 83 valve splitter, an EZ 81 rectifier valve, and two EL84s, push-pull, multilinear. So the complaint was that it's humming. I scoped it, had a look on the old scope with a dummy load, and it didn't look too bad to me. So obviously, like the bloke who owns it isn't hearing things, so I don't know if you can hear that. I've heard worse, but it's not brilliant. However, this is the back panel. I'll point you near the speaker. So obviously that makes a difference. So obviously when you put that in there, it's capacitively coupling any hum into the circuit. So let's turn this off so we don't get shocked. First thing I did when I got this amp was to have a look at it, to look at the layout and just look for obvious things. So first off, this is a reservoir, main reservoir capacitor. You see we've got a bulge. Now I had a look at the HT voltage. That was a little bit above working voltage, DC wise. AC wise it wasn't too bad at first. Come back to that later. And there's another capacitor, 3-section capacitor in there. That one showed bad ESR on one section. I haven't checked them for leakage yet, but the main thing that jumps out to me in this amplifier is the grounding. The grounding is all over the shop. So just starting here, we've got the earth coming in, and then here we've got, looks like the centre tap to the HT, and that's going to the earth on the IEC mains inlet. So we've got a main centre tap, a main HT winding centre tap going there. That's sort of soldered onto this tag of this capacitor holder, and then we've got the can is soldered onto the other side of this cap holder thing. And then we've got a similar sort of thing going off all over the place. So here, this black wire, that's our heater winding centre tap. That's going over to here on another ground. So that's grounded there, and that's going to be grounded through the chassis. We've got another ground here, 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 another one here, another one here. So we manage that 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10 different ground points to the chassis. So obviously that is a potential for ground loops. Not good. This would be a lot better if it was grounded to one main ground bus and basically, you know, a proper grounding scheme, all basically tied back to our first main reservoir smoothing capacitor. I'll just spin you around a little bit. These are my speaker leads, and then we've got this sort of bus bar here, which is connecting various points of the tone controls volume pots. I will show you the schematic in a minute. This 10 meg resistor here is coupling, basically the first stage is got local feedback, and that's part of the local feedback loop. I found a few other potential problems. That's a ground, not too bad, but some of these, well, this was sitting right down here, so we've got HT going through there. That could like arc out on there. What else have we got? There's a few bits like that we've got high voltage near to the chassis. Not good. Two other things. These are our grid, what do you call it? Grid stoppers. These are far too big. 200 ohms. Don't need to be these great big 5-watt jobbies. This is our main, basically these two EL84s are going through the same cathode bias resistor. This is the cathode bias resistor. This is the cathode bypass capacitor. They would be a lot better if they were side by side going to the same ground point. So you've got basically the coupling, the bypass capacitor on one EL84 and the cathode resistor on another EL84, different grounding point. However, they are joined by this sort of blue wire here and this sort of wire here. It's, yeah, it's all over the shop. So bloke hasn't got a lot of money to spend. I don't really want to spend a lot of time doing it. The ones I've seen on the internet that other chaps have done, they basically used a tag board, put all the components on it and cleaned the component layout, doing it that way. I haven't got a tag board, I don't think, anyway, and I'm going to try and do that. I'm going to try and tidy it up without using a tag board, and to keep the cost down. Oh, one last thing. This is the secondary output of the output transformer. These 2 points here are 16 ohm, and then there's 3 and 3. So this being a center tap, I'm wondering if there's a way we can reconfigure. It looks like basically there's 2 secondaries wired in, what would it be? I'm not quite sure till I have a look. They're either wired in parallel or series parallel, I'm not quite sure. We can have a look at swapping those round for a more conventional 8 ohm nominal load. What else is there? What else? Oh right, when I tested it, the 2 volume controls, which are here, the 2 volume pots, basically got a high and a low input. They interact, so this turns up channel 2 and this turns up channel 1, so that's not good. There's some sort of crosstalk going off there. Blah blah blah. I think that's about it for now. Just one sort of final word on these amplifiers. They were cheaply built. Some were made for kits, as kits. Others were made in the factory. They used cheap transformers, built down to a price. But, you know, they're alright, do the job. This is supposed to be 12 watts, something like that, which is about right for a couple of EL84s. And that's about all there is to say about it. So I'm going to go and try and work out some sort of scheme for improving the layout, but without doing too much work. Progress. I've sorted the main side out. Oh, that shouldn't be in there. Just chucking all the wire out. All this spare wire's come out. Right, so we've got, first off, we've got a dedicated mains earth strapped to the chassis. with 2 bolts on, a lock bolt on there, proper crimps, what do you call it, eyelet thingy. We've replaced the mains cable coming in with proper coded brown for live, blue for neutral, and I've put this old fuse holder in here. So now the live side is fused, goes into the main switch. It's only a single pole, single throw, and that goes straight into the primaries of the mains transformer. On the, let me just go and get the schematic, try not to spin you around and make you dizzy. So here's the circuit. So if you see on the primary side, on the main side, it was fused on the neutral with just a switch there. Well, I think that's not right. I know it's not right. So there's no fuse on the neutral now. So the fuse is on the positive side, sorry, live side, not positive, don't call it positive. And then we have, so before, if you remember, we got the centre tap to the heaters going over to here, to this sort of chassis ground, and we had the centre tap of the HT going over to here. So now they're twisted together and they're going, as should be, I'll try and see, they're going to the negative or the ground tab of this new smoothing cap, which is a 50 microfarad, 50 microfarad. The old one in there was 3232. This is an EZ81, so they can handle 50 microfarads if your transformer impedance is over 240 ohms. This is 280 ohms to the centre tap, which is 200, 400, 560 from, easy if I point to that. Sometimes my brain doesn't work. You know what I'm like, I find it hard to get my words out. So the DC resistance of this mains transformer is 560 ohms from these 2 points here. And so all that's in. One other thing, I twisted the heater supply to the EZ81. So that's looking a lot neater, isn't it, I think. It's a lot safer too, because the chap intends to use this to take it to record fairs to demonstrate 78 records. And if some sort of punter, customer, sorry, is the correct word, comes and gets an electric shock off here, I mean these are usually elderly gentlemen, he's selling 78s, we do not want dead elderly gentlemen at record fairs, do we? So the next thing to try and do is sort all this lot here. So how do you start? Well, the simplest place to start is at the output. All valve amplifiers, you work backwards. Obviously the signal comes in here, but it helps from a design point of view and construction point of view to think of it going this way. So basically all your high current is going into this output stage. That's where you want all your power supply going in, your main ground going in. All this comes, lower current stuff comes in afterwards. I hope that makes sense. So I'm thinking, right, we need a bus bar. We need a bus bar coming in from this negative tab to somewhere. So on amplifiers it should only be grounded to the chassis at one point, and that's how you get input. So we've got an input here with mains earth colour coded for the ground, which I don't like. It won't take long just to whip that off. So that's where normally our chassis ground would be. I don't know, we'll think about that, and that's a minor issue. So as specified, as said, me and my words, these are coming off, and we shall take them off and we shall run a bus bar from, this is basically our sort of live side of our output of a secondary winding of our output transformer. So this is the ground for now. So I'm going to take a bus bar off there and sort of run it here somehow, I'm not quite sure where. And then my idea was to pick up some of these grounds as I go along. So what I'm trying to do, as I said, is to make it neater, improve the grounding, stop the hum, but I don't want to be doing too much alteration and too much work. Right, I'll crack on.